I dedicate this video and the next few videos to a student who wants to try and understand this stuff a bit better. I'm going to try and make this as simple as possible. So this is Year 10 Science Motion, looking at quantities of motion. So motion involves things like speed, distance, time, acceleration. I'm going to start with distance. Distance, quite simply, is the length between 2 points. Okay, looking in terms of like one dimension, okay, a straight line. 2 points, point A, point B, that's distance. And in physics, we usually use the units of meters, the meter, lowercase m, or the kilometer, lowercase k, lowercase m. That's distance. Now, displacement is how far you are from your starting point. We usually use d in physics for distance, d for distance. Displacement is how far you are from your starting point. So suppose this is point A. Let's suppose I go from point A to point B, and then I go back to point A. My displacement is 0 because my starting point is A. When I go and come back, my displacement hasn't changed. However, let's suppose I go from point A to point B and I stop at point B. Let's suppose this distance here is 10 meters. Then my displacement is 10 meters to the right. So distance is what's called a scalar in physics. A scalar quantity is just a number. Okay, temperature is also a scalar. 10 degrees Celsius, that's a scalar. 10 grams, mass is also a scalar. So a scalar is just a number. Displacement is what's called a vector. Think of a vector as like an arrow. A vector is something. A vector is basically a scalar, a number, with a direction. So these are very important words you have to know. So if you look here, displacement, I've written 10 meters to the right. You can also write plus 10 meters. The plus means, look at the direction, let's say the x-axis, you've got plus x going to the right, minus x going to the left. Okay, if you think of a number line and there's y there, the plus x means it's to the right of the origin here, the y-axis. So you can also write plus 10 meters. And displacement in physics is given the symbol s. Okay, sometimes with an arrow on top to indicate it's a vector, but s is fine. S is displacement. So d for distance, a number. Displacement is s. So it's a measure of how far you are from your starting point. Another example, or another way to think of this is if you start your day at home, you go to school and you come back, your displacement is 0. However, if you start at home and let's say go to a friend's house, 5 k's away, your displacement is 5 kilometers, let's say northeast from your house. So that's the key difference between distance and displacement. So we've done distance and displacement. Let's now look at speed. Now, speed is something we're all familiar with. Just look down at your car's dash, the speedometer. There's like a dial here. You've got the different speeds here. You'll see things like, 10 k's per hour, and so on and so forth. Speed is how much distance, d, you cover in a certain amount of time. T, lowercase t. We use lowercase t for time in physics. So you can represent this mathematically using a formula. It's very simple. Speed is given the symbol v. Okay, I know it should be s. Sometimes they use s, but it's usually v. In physics, v is speed. Speed is distance d, as we've mentioned now, over time. How much distance you cover in a certain amount of time. The words you cover is represented by a fraction. So that's your formula there for speed, and hopefully they should give you this in an exam. So 10 k's per hour means literally you've covered 10 kilometers in an hour. 50 k's per hour means you've covered 50 kilometers in an hour. The higher the speed, the more distance you cover, if that makes sense. Right, you cover more distance when you're doing 50 k's per hour as opposed to 10 k's per hour. And speed is a scalar. It's just a number. If you look down on your car's dash, you'll see a number. That's speed. There's also velocity. Now, velocity is the same thing as speed, but with a direction. So we write V for velocity. We put an arrow on top, usually. So velocity is a vector, I should mention. A vector is a number with a direction. And velocity is given by the following formula. V is equal to S, the displacement, divided by time. We use displacement because displacement is a vector. Velocity is a vector. It's got an arrow because displacement is a vector. It's not distance, it's displacement. So let's suppose there's a wind coming in at 50 k's per hour northeast. That is velocity because it has a number here and a direction. 50 k's per hour, that is speed by itself, just a number. So that's velocity in terms of displacement. There's another thing called acceleration. So I'm sure these are words you've heard before, you're familiar with from everyday life, but mathematically it's really just the same thing. It's just using symbols and numbers. So acceleration, we use a, lowercase a, for acceleration is equal to the change in velocity over the change in time. That's your formula. It's basically how fast, or how much, I should say, how much your velocity is changing. Acceleration is a vector because velocity V is a vector. So suppose, and the units for acceleration, I should say, because the numerator here, the delta V, the units for, I should have specified this before, but that's all right. The units for velocity is the same as the units for speed, which is meters per second, let's say. It could be k's per hour too, but meters per second, let's say, typically. And time has units of seconds. So the units, therefore, for acceleration are meters per second squared. Okay, because there's 2 seconds, you have this, get meters per second squared. That's how you think of it. Okay, and let's suppose you're moving at 2.2 meters per second squared west. That is acceleration. You have to have a direction. That's not an acceleration there. That is an acceleration there. Okay, so these are really the basic formulas, the basic quantities of motion. I should stress as well here, acceleration. So I'll rewrite it here. Acceleration, I'll just leave out the arrow for now. Delta V over delta T. Delta means change in. Okay, physicists, we're lazy people. We don't like to write a lot of words and sentences. We like to use symbols and maths to make things easy. Change in, it's the Greek symbol, capital delta. It's a triangle with one part shaded, one of the sides shaded more than the other. Delta V, the change in velocity, is your final velocity V minus your initial velocity U. And delta T is usually the final time minus initial time. That is your final velocity. And that's your initial velocity. You can also use, just a note for the numerator, V sub F minus V sub I, where V sub F is the final velocity and V sub I is the initial velocity. You can use that. Okay, so acceleration is how much your speed's changing over time. We can do some calculations, some simple ones. Let's say you need to find the speed if distance is 10 meters and time is 2 seconds. Step 1, write down what we know. We know what the distance is, 10 meters. We know what time is, it's 2 seconds. How do you work out speed? Well, if you go to the formula sheet, if you go back up, speed is just V equals D over T. Step 3, you substitute your numbers. So V is just D, which is 10 meters, over T, which is 2 seconds. If you do the maths, 10 over 2, that's 5 meters per second. Okay, because meters divide seconds. Let's do another one. Let's do one involving acceleration. Suppose initially a car is at rest and then moves at 10 meters per second for 5 seconds. I'm just making these numbers up. They might not be realistic. Just making them on the spot. What's the acceleration A? Now, here's how you dissect this. You're actually given more than what you can see. Initially, at rest means your initial velocity u is 0 meters per second. If you're not moving, your speed is 0. So u is 0 initially. Then it moves at 10 meters per second. That's your final velocity, 10 meters per second. And for 5 seconds, that's time. T equals 5 seconds. We need to work out A. Number 2, what do we know with acceleration, the formula? It's right here. Delta V over delta T, which is V minus U over T. In this case, we're assuming that time starts at 0. T equals 0, and it goes up to 5 seconds. I'll actually do this to make things easy for you. Final time minus initial time. 3, we sub. So let's sub in. A equals, so V is 10 meters per second, minus U, which is 0 meters per second, divided by final time, which is 5 seconds, minus initial time, which is 0. You always assume it's 0 if you're only given one time. 10 minus 0 divided by 5 minus 0 is 10 over 5 seconds. And that's 2 meters per second squared. Now, there's no direction here. Let's suppose it's moving to the right. You will say to the right. And that's how you do that. So for the student I've dedicated this video to, make sure you just make up some questions of your own or look them up online and use the same recipe. So these are really just simple ways of solving motion problems involving, let's say, speed or acceleration.